Hello, I am Mingqi Han, and this is the video explanation of homework 1, question number 5. In this question, there are two methods proposed for testing 100 people for a kind of disease, which is the probability of people having the disease is 0.1 for each person. And there are two methods. First one is to do all 100 people, 100 tests. And method 2 is that to divide 100 people into 10 groups with 10 people on each group. And then for the group that have a positive result, do the second round of test for that group specifically, which adds 10 more tests to the total. The question is to find on average, what is the number of the tests we need to do for the method 2. So to solve this problem, we can first discuss the situations that under what situation we need to take the round 2 of testing for a group, which is that there are two cases. The first case is that there are no person in the group tested having the disease, so their mixed sample have no positive results. This group don't need a second round of test. And the second case is at least one person in the group have the disease and the test shows positive. So all of the 10 people in this group need to be tested for the second round. So we need to first calculate for each group, what is the probability of this group have to take the second round, right? So in order to calculate this, we can either figure out the probability of one person having the disease, and two people have the disease, 3 people have the disease, all the way to 10. All people have the disease in this group, but that's a lot of calculation. We can simply just do that. No people have the disease, which is 0.9 for each people to the 10, which is 10 people in the group, which is approximately 0.348, something. And this is the value for the group not having to do the second round of test. And for the group that have to do the second round of test is 1 minus that value is 652. This is the probability of the group having to take the second round of test. And if there are enough amount of groups, let's say not just 10, or let's say there are infinitely many groups, there are 65% of the groups that needs to be tested. But here we have 100, just 100 people and 10 groups, so we need to calculate the expected value, which does not need to be the same integer as the number of groups. It can be just under 100 people times to 0.652, which is approximately 65 tests needed for the second round overall for all 100 people. So this is the test that we need for the second round. Adding the first round 10 tests to this 65 second round, we get 75 tests for the expected value of method number 2. What's interesting about this is that we can also calculate on what probability that one person have a disease that method number 2 is better than method number 1, which this becomes X. We don't know that, but we do know that method 2 is better than method 1, which means that this is less than 100, this is less than 90, and this value is 0.1. So if my remembers is correct, 0.8 to the 10th yeah, it's approximately 0.1. So we get that if the probability of people are not infected, if that value is equal to 0.2, method 2 is always better than method 1, approximately.